Hey guys, we're going to start our first chapter today on comparing functions. That's our first section. Our first chapter is functions. And we're going to actually take this chapter and break it up into two different parts for two different assessments because it is kind of a lengthy chapter. So we're going to start by comparing functions. There are going to be some things that you need to fill in with your notes. So just make sure you pause your video so that you can do that. Two objects are dropped and information on how they dropped are given below. Object 1 is in a graph, object 2 is in a table. So we're looking to compare functions where they're not in the same format. So which object was dropped from a higher building and how do you know? So as you're looking at object 1 and object 2, the way that you'll know which one is dropped from the highest building is you look at time t equals 0. So at time t equals 0, object 1 is at 11 feet and object 2 is at 20 feet. So which one is dropped from the higher building? Object 2. Which object hits the ground first and how do you know? So you look for at y equals 0, what's happening? Object 1 is at 2.5 seconds and object 2 is at 5 seconds. So object 1 will hit the ground first. Jimmy, Bob, and Daniel are all competing to see who can run the most miles in a month. Use the information below to answer the questions. So what we're going to do before we start answering our questions is find our equations that will match each scenario. So we have 0 days, 10 miles, 2 days, 20 miles, 4 days, 30 miles, and 8 days, 50 miles. So if we were to find the slope, we would say 20 minus 10 over 2 minus 0. So 10 over 2 is 5. So we have a slope of 5 and a y-intercept of 10. So this is y equals 5x plus 10. This means when he started, he had already run 10 miles. So he may have done that the prior week. Daniel has already run 15 miles and he's running 3 miles each day. So he's running 3 miles each day. He's already run 15. And for Bob, on day 0, he has run 0 miles. But on day 1, he's run 7, and on day 2, he's run 14. So our slope here, 14 minus 7 over 2 minus 1 is 7. And the y-intercept is 0. So this function is y equals 7x. So which runner is running the most miles each day? So how much is each runner running each day? Look at the slopes. So Jimmy is running 5. Daniel is running 3. And Bob is running 7. So who's running the most miles each day? Bob. Which runner had the most miles when they started? Daniel. He had 15. All right, who will run 50 miles first and explain how you know? We're going to type these functions into our calculator. And then we're going to look at the table. So we have 5x plus 10, 3x plus 15, and 7x. So we're going to look at the graphs. They're all lines. They should all be no curves in there. And so second graph. And so we're looking to see which one will run 50 miles first. All right, so on day 7, we have Jimmy, who has run 45, and Daniel has run 36 and Bob has run 49, which means Bob will hit the 50-mile marker first because he's already at 49 at the end of day 7. So on day 8, Jimmy will have run 50 miles, Bob 56 miles, and Daniel 39 miles. Bob will run 50 miles first. So Bob is our answer for number 5. We're going to do some matching here if you guys want to take a second and pause your video so that you can get your graphs down. We're going to match the equation with the function type. So taking a look at graph A, graph B, and graph C, we're going to match graph A with an equation and a function type. So here's graph A. So it's a line. So which one of these is a line? H of x equals 4t minus 6, and we've already said it's going to be linear. In graph B, you can use process of elimination if you're not sure. This is an exponential function. And graph C is a quadratic function. Now we're going to answer some questions about the graphs. Of the 3 graphs above, which graph has the highest y-intercept? And explain how you know using 2 different methods. Y-intercept. All right, so our methods are, we can look at a graph, and we can also look at the table from the graph. So it appears that it's either A or B in terms of which graph has the highest y-intercept. But we're going to go with B because it's exponential. So if nothing else, it's going to be growing farther, faster. Questions on that, make sure you mark with a sticky note. And of the 3 graphs above, which graph is moving at the fastest rate? Well, we kind of just answered that. B rises fastest. And it is increasing exponentially. All right, given the 2 functions below, answer the questions. So here's the first function, it is an equation, and here's the second function, and it's a graph. This is not the graph of that function. So what do the 2 functions have in common? Well, first of all, they're both quadratic. They both open down. They both have a maximum. And they both have a negative coefficient of x squared. So what's the same? Or excuse me, we just did what's the same. What's different? Their max heights are different. And we would know that when we graph P of t. As are their x-intercepts. So I could have answered 8 by myself without graphing P of t, but I would probably need to graph P of t in order to answer question 9. So here's the graph of P of t. You know their max heights are going to be different. This one is at x equals 5, 25. So let's just zoom out, zoom 3, so you can see where the max height would be. There it is. And you can trace it. Second trace, max 4, left, right, and inner. 3.75, 28.125. So you can see they're different there. And the x-intercepts I can trace is going to be, it's not going to be to 10, it's going to be around 7.5. All right, last page here on comparing functions. I want you to take just a minute and I want you to pause your video and I want you to see if you can figure out, this is what you have, and I want you to see if you can figure out what goes in the y. Like, why does the function f of x increase faster than graph A? So take just a minute and see if you can figure that out, and we'll come back in just a second. All right, I hope you've had a chance to answer these questions. Let's see if what you had is correct. If it's not, just make corrections there on your paper. So the function f of x, 5 to the x power, increases faster than graph A. Why? You should have something along these lines. Because graph A is a linear function that increases at a constant rate. F of x is an exponential function that increases at an exponential rate. If I can get that S out of there for you. All right, g of x equals x squared plus 1 is not linear. Why not? Because it is a quadratic function. Its highest exponent is 2. For linear, its highest exponent is 1. The table represents a linear function and the graph represents an exponential function. Why? Because the x and f of x, having some trouble today, values in the table increase at a constant rate. It represents a linear function. The graph is an exponential function. Because it shows a curve that increases rapidly. You may find from time to time I give you assignments that look like this, where I give you a scenario and you have to explain what's going on and why it is what it is. All right, as always, pause your video whenever you need to catch up. All right, what I'm showing you here is in your module under the assignment for comparing functions. And your task is to match each graph with an equation, a table, and a rule. And so we did something very similar to that here. So over on the back, you have a graph, an equation, a table, and a rule. So you are going to fill the information out here in the chart and then explain how you matched each of the four graphs to its equation. If you need to use process of elimination, let me know if you guys have any questions. And I hope you all have a great day.